Usually when we talk about a medical diagnosis, there's this, I don't know, this expectation of precision.
Right, yeah, like it's engineering or something.
Exactly. It feels almost like engineering. Like if you break your arm and you go to the hospital, the X-ray shows that jagged white line on the screen. And the doctor just points at it and says, there it is. That is the problem.
Yeah, it's entirely binary in that context, right? I mean, the bone is either broken or it isn't.
Right.
The mechanical failure is visible, so the solution is just to mechanically set it back into place. And I think we have been conditioned to expect our bodies to operate with that kind of straightforward, visible causality.
But then you step into the world of systemic health.
Yeah.
Things like neurodevelopment, trauma, and aging. And suddenly, that X-ray machine is completely useless.
Oh, completely. It's a totally different paradigm.
Yeah, you're looking at a diagnostic landscape that is incredibly murky. Like, we are trying to pinpoint why some people thrive into their 90s with, sharp minds and resilient bodies.
While others begin this steep biological decline in their 50s. Yeah.
Exactly. And today, we are exploring something we are calling the architecture of longevity. And I really want to set the parameters for you, the listener, right out of the gate here.
Because we are moving far beyond standard surface-level health advice today.
Right. We aren't going to just sit here and tell you to eat a salad, go for a jog, and get 8 hours of sleep. I mean, we've all heard that a million times.
Yeah, because those are just the external symptoms of a functional system. What we are examining today are the foundational biological, chemical, and mental systems required for true vitality.
Which is such an exciting way to look at it.
It really is. We're
Yeah.
connecting the dots between microscopic cellular actions, the way your immune system reads epigenetic data, and, well, the broader landscape of how you process psychological stress in your daily life.
So if you really want to understand longevity, you have to look at how all these distinct layers interact. You have to see how they build a resilient structure.
Right, because if you don't look at the interactions, you're missing the whole picture.
And we have a fascinating stack of material to get through today to help us see that picture. We've got clinical trials, biochemical research, and some deeply revealing expert anecdotes.
Yeah, we're pulling from cellular biology, emergency medicine, habit formation, and even existential psychology.
And honestly, looking at all this material together, it fundamentally shifts the paradigm of how we view aging and survival. It's just wild.
It's not just a matter of adding chronological years to your life, It is about reinforcing the structural integrity of the time you actually have.
Which is exactly why that architectural metaphor works so perfectly here. I mean, you cannot build a lasting structure without a solid foundation at the cellular level.
Exactly. And then you need strong, load-bearing walls, right? Built from your daily physical systems. And finally, a roof made of your social and psychological connections.
And if any single one of those layers is compromised, the entire building is at risk.
Regardless of how optimized the other parts might be, the whole thing can come down.
Okay, let's unpack this. I want to start at the absolute foundation, the cellular and immune levels. Because, before we can talk about surviving acute crises or building resilient habits, we have to look at how our cells are programmed to age in the first place.
Right, we have to look at the baseline. And for decades, the general consensus was that aging was basically just wear and tear.
Like a car rusting over time, just inevitable decay.
Exactly, like rust. But the research from Dr. Cynthia Kenyon completely upends that idea. I mean, she was running these extensive experiments on these microscopic worms called C. elegans.
C. elegans, and why those specific worms?
Well, C. elegans are a massive staple in genetic research. They have a very simple, fully mapped genome, and their natural lifespan is only about 2 to 3 weeks.
Wow, 2 to 3 weeks, so it's incredibly fast.
Right, which means you can observe multiple generations and measure lifespan variations very quickly. So Dr. Kenyon's lab was looking for genetic pathways that might influence how fast these organisms aged.
And what she found was staggering, right? By mutating just a single master control gene, she could literally double the lifespan of these worms.
Double it. And they weren't just living longer in some decrepit state either. They were staying young and active for twice as long.
Which is insane. But the mutation wasn't giving them some sort of, superhero armor, was it?
No, it wasn't about adding anything new. It actually had to do with insulin signaling. Specifically, the mutation slightly inhibited the insulin and IGF-1 signaling pathways.
Okay, IGF-1, that stands for insulin-like growth factor 1, right?
Yes. In a normal state, when resources meaning food and energy are abundant, your insulin and IGF-1 pathways are highly active. They tell the body cells to grow, to proliferate, to build.
So it's a state of expansion. The body thinks times are good. Let's build a new deck on the house.
Exactly, it's expansion. But what Dr. Kenyon discovered is the biological flip side of that coin.
Because when she mutated the gene to slightly inhibit that pathway, she essentially tricked the worm's biology. She sent a fake message.
Yes, the organism interprets that subtle inhibition as a sudden scarcity of resources. Even if the worm has plenty of food in its environment, the genetic mutation prevents the cells from fully receiving the signal that food is abundant.
So the body receives a false danger signal. It basically believes winter is coming, so to speak.
Right. It thinks, uh-oh, resources are low.
I think of it like running a cellular fire drill. You are stressing the system just enough, sounding the alarms, so that everyone in the building snaps to attention.
That is an excellent way to visualize the mechanism. It really is like a fire drill.
Yeah, the body thinks things are getting bad out there. We don't have the energy to grow right now, so we need to protect and repair what we already have.
Exactly. You ensure the building's defenses are absolutely perfect, so when a real fire happens later, the cells are already fortified.
So what actually happens during that drill?
Well, when that false danger signal triggers, the body initiates a massive system-wide resiliency response. At the molecular level, it activates transcription factors.
And those are just proteins that turn other genes on or off, right?
Yes, they tell the cells to start ensuring that proteins are folding perfectly. It drastically ramps up the production of antioxidants to resist oxidative damage.
So it's a really deep evolutionary survival mechanism.
It is. The organism is battening down the hatches to survive the perceived famine. And the biological byproduct of that intense defensive posture is a dramatically extended lifespan.
Okay, I'm trying to square that with how we actually live our lives.
Mm.
Because obviously we aren't microscopic worms in a petri dish, right?
Right. Sadly, we are a bit more complex.
And we can't just go in and mutate our own master control genes. But Dr. Kenyon actually applied this underlying principle to her own life to mimic the effect, didn't she?
She did, yeah. To recreate that exact longevity effect, to keep her insulin and IGF-1 pathways inhibited and maintain her cells in that constant state of repair, she adopted a strictly low-glycemic diet.
Like an Atkins-style diet, meaning she completely cut out refined white carbohydrates. No potatoes, no bread, no sugar.
Precisely. By doing that, she keeps her blood sugar and consequently her insulin levels consistently low.
Oh, wow. So she is manually triggering that cellular fire drill through her daily dietary environment.
Yes. Without the constant spikes in insulin that come from a high-carbohydrate diet, her body remains in this subtle, persistent state of resource conservation and cellular repair.
It's basically a behavioral intervention that mimics a genetic mutation. That is so cool.
It really is. Diet serves as the chemical trigger for this cellular fire drill.
Which brings up a critical question for me. If diet can manipulate our baseline genetic expression, how deeply does that affect the systems we rely on to survive day-to-day threats?
Well, that leads us straight to the immune system.
Right. I was looking at Dr. Jeffrey Bland's immune research, and he makes a massive, almost definitive claim. He states that the immune system is the single most important predictor of human longevity.
And he's right. When you look at the architecture of the human body, the immune system is the ultimate arbiter of what belongs and what doesn't.
It's the security system of the building.
Exactly. It manages inflammation. It clears out senescent cells, which are those zombie cells that stop dividing but refuse to die, and instead they just secrete inflammatory toxins.
Ugh, zombie cells. And it also constantly patrols for pathogens.
Right, and if your immune system becomes dysregulated, it either fails to protect you from external threats, or worse, it begins attacking your own healthy tissue.
And the timeline he gave for how this system operates just blew my mind. I mean, he noted that the entire cellular system of your immunity essentially replaces itself every 4 months.
Yeah, you get a completely fresh immune system 3 times a year.
That is wild.
The turnover rate of white blood cells and other immune components is incredibly fast. And this is where the connection to diet becomes structural rather than just energetic.
Right, because Dr. Bland's data indicates that 40% to 60% of the information your newly regenerating immune system receives comes directly from what you consume.
Which is a huge percentage.
Wait, let me make sure I'm fully grasping the implications of that. If I eat a terribly inflammatory diet for 4 months, am I physically constructing my next immune system out of substandard materials?
It is actually deeper than just the materials. You are providing it with corrupted instructions.
Corrupted instructions.
Yeah. To prove this, Dr. Bland's team orchestrated a massive 90-day, double-blind, placebo-controlled clinical trial. They tracked 850 participants.
Okay.
And the intervention they used was Himalayan tartary buckwheat.
which is a very specific ancient plant, right? From what I understand, it grows in incredibly harsh, high-altitude climates.
Yes, very harsh environments.
And because it has to survive freezing temperatures and poor soil, it produces massive amounts of polyphenols, these dense stress compounds, to protect itself.
And what's amazing is that those polyphenols are highly immune active when consumed by humans. In this trial, the researchers were tracking the epigenetic expression of the participants' immune cells.
I really want to pause on the epigenetic data here because the pilot study results are almost difficult to believe.
They are definitely shocking.
The participants who consumed the buckwheat experienced a 20-fold positive change in their immune cell expression, a 20-fold improvement. And they didn't alter any other lifestyle factors.
Nope, nothing else.
They didn't start meditating. They didn't implement a new exercise regimen. They didn't move to a cleaner environment. They just integrated this highly specific polyphenol into their diet for 90 days.
Just the buckwheat.
Is the human immune system truly that malleable? I mean, how can one single dietary intervention rewrite an immune response to that extreme degree?
What's fascinating here is that it requires us to completely reframe our definition of food. In modern culture, we are conditioned to view diet purely as fuel.
Right. We think in terms of thermodynamics. You put calories into the machine, and the machine burns those calories to produce kinetic energy.
Exactly. But Dr. Bland's epigenetic research demonstrates that diet is not just fuel, it is literal software code.
Software code. So it's actively programming the hardware.
Yes. Let's break down epigenetics for a second. Your DNA is your hard drive, right? It contains the static blueprints for everything in your body.
But those blueprints have to be read and transcribed.
Right. Epigenetics involves chemical tags, like methyl groups, that attach to your DNA and act as volume knobs. They turn the expression of certain genes up, down, or off entirely.
Oh, I see.
So when those participants consumed the Himalayan tartary buckwheat, they weren't just getting calories. They were ingesting complex polyphenols that acted as newly optimized lines of code.
And because the immune system is actively regenerating its entire fleet of cells every 4 months, it takes that new code and immediately applies it to the fresh batch.
Exactly. The polyphenols physically interacted with the epigenetic tags on their DNA. They upregulated the genes responsible for immune resilience, and they downregulated the genes that cause chronic inflammation.
Wow. So the buckwheat didn't just give them a temporary energy boost. It fundamentally reprogrammed the operating system of their regenerating immunity.
That is exactly what happened. It's a total software update.
That reframing changes everything. We have this foundational baseline now. We can intentionally inhibit our insulin signaling to run these cellular fire drills, and we can utilize complex plant polyphenols as software code to optimize our immune system's regeneration cycle.
Right. That's the ideal baseline.
But life is not a controlled 90-day clinical trial where everything goes according to plan.
Yeah.
I mean, we face sudden, acute emergencies.
We do. And we harbor hidden chronic disruptions.
Right. So if the baseline is optimized, what happens when the architecture suffers a sudden impact?
Well, this introduces the acute layer of our architectural model. When a severe physiological emergency hits, the slow 4-month epigenetic regeneration of your immune cells is irrelevant.
Yeah, you don't have 4 months. You have minutes.
Exactly. You need immediate mechanical biochemical intervention to keep the system from collapsing.
Here's where it gets really interesting. I was reading Dr. Tina Moore's clinical insights on this, specifically regarding severe acute dehydration.
Oh, her work on this is fascinating.
Right. And we are not talking about feeling a little parched after a light jog here. We're talking about clinical dehydration, sudden confusion, deeply sunken eyes, plummeting blood pressure, a racing, thready heart rate.
The body is in a state of hypovolemic shock.
Yes. The vascular system is crashing because there isn't enough fluid volume to keep the blood pumping to the brain and organs. And Dr. Moore points out a massive misconception. In that acute state, just giving someone a glass of plain water to drink is not going to save them.
It won't. It is a critical misunderstanding of cellular biology. If your blood pressure is dropping dangerously low due to severe fluid loss, pouring plain water into the stomach won't diffuse into the bloodstream and enter the cells fast enough to reverse the shock.
Really? Why not?
Because water alone doesn't have the necessary osmotic pressure to rapidly pull itself across the intestinal lining in an emergency.
Which is why she points to the World Health Organization's emergency rehydration formula. The WHO protocol calls for 1 liter of water, a half teaspoon of salt, and 6 teaspoons of sugar. Sugar. I mean, we just spent the entire first section of this deep dive talking about how inhibiting insulin and cutting out sugar is the key to running cellular fire drills and extending lifespan. And now, the protocol for acute survival demands pure sugar.
I know, it sounds completely contradictory, but this is the vital distinction between long-term longevity optimization and acute survival mechanics.
Okay, walk me through that.
In a state of severe dehydration or shock, your cells are desperately starved for sodium and water to restore blood volume. But biologically, sodium cannot simply drift across the cellular membrane on its own at the speed required to save your life.
So it needs help.
Yes, it requires an active transport mechanism. And in the human gut, the primary mechanism for this is the sodium-glucose cotransporter protein.
The sodium-glucose cotransporter. So glucose is biologically required to drive the sodium into the tissue.
Yes, for the protein to activate and pull sodium across the intestinal wall and into the bloodstream, a molecule of glucose must bind to it alongside the molecule of sodium. They have to cross together.
Oh, man. I picture the glucose as the VIP bouncer at a very exclusive club.
Huh, that's a good way to look at it.
Right. The sodium is outside, desperately trying to get into the cell to save the party, but the door is completely locked. You could have all the salt and water in the world waiting on the sidewalk, but until the glucose bouncer comes along, opens the door, and physically escorts the sodium inside, nothing gets absorbed.
The mechanism is exactly that rigid. The gut requires both molecules to turn the key. And Dr. Moore shared an incredible visceral anecdote that perfectly illustrates how instantaneous and powerful this physiological mechanism is in the real world.
I remember reading that. She was out at a club, right?
Yeah, and a young man accidentally suffered a severe laceration to his hand.
The scene she described was horrific. He had severed a major vessel. He is actively bleeding out on the floor, his blood pressure is in free fall, and his skin is turning pale and clammy as his body shunts blood away from his extremities to protect his vital organs.
And before the paramedics can even arrive, Dr. Moore steps in. But she doesn't try to force him to drink water, which he might choke on in his compromised state anyway.
Right.
Instead, she takes packets of emergency salt and places the salt directly under his tongue.
Sublingual absorption.
Exact.
And she noted that it almost instantly stabilized his crashing blood pressure. It helped slow the systemic panic and brought the pink color back to his face.
Just from the salt.
Just pure salt, dissolving under the tongue, absorbing directly into the rich vascular bed there, and entering the bloodstream to instantly pull extracellular fluid back into his veins and stabilize his blood volume.
It is a profound demonstration of the tension between acute survival and long-term health. In a life-or-death crisis, you do not care about cellular fire drills or IGF-1 inhibition.
Not at all.
You hijack the pure, raw physiological mechanics of sugar and salt to force immediate transport and maintain blood pressure.
But once the immediate crisis is averted and the patient is stable, you have to transition back. You have to look at the long-term integrity of the system, particularly the gut.
Right, which is where all this daily absorption actually takes place.
And the gut is truly the hidden command center of the body. I mean, if your gut is compromised, your baseline immunity and your daily nutrient absorption are completely derailed.
Absolutely.
I was looking at Dr. Isabella Wentz's approach to this. She focuses heavily on identifying the root causes of chronic gut issues, like irritable bowel syndrome.
Yeah, and she argues fiercely against the standard medical model of just medicating the downstream symptoms.
Right. If you have diarrhea, they give you an antidiarrheal. If you have acid reflux, they give you a proton pump inhibitor. But she argues that you have to look deeper for hidden protozoal infections, parasitic overgrowths, or severe food sensitivities.
Because if you just suppress the symptom, the underlying fire is still burning. You are basically just turning off the smoke alarm.
And Dr. Wentz herself suffered from this, didn't she?
She did. While she was going through pharmacy school, she developed severe explosive diarrhea that standard medications couldn't fix.
And she eventually realized it wasn't a biological malfunction of her bowel at all. It was a profound sensitivity to soy.
Exactly.
She completely resolved her debilitating symptoms simply by identifying that single dietary trigger and removing it, allowing the acute inflammation in her gut lining to finally subside.
Which represents a vital shift from symptom management to root cause resolution. However, this introduces a highly complex dietary conflict when you cross-reference her experience with the clinical protocols from nurse practitioner Cynthia Thurlow.
Yeah, this is where I found myself incredibly conflicted when reviewing the research.
Yeah.
Because Thurlow enters the conversation, and her entire focus is on bridging what she calls the American fiber gap.
Right, a fiber gap.
She points out that the vast majority of people are severely deficient in dietary fiber. She argues that massive fiber intake is absolutely crucial for stabilizing midlife hormones and reversing insulin resistance.
And she has the data to back it up.
She cited a 16-week randomized control trial focused on menopausal women who were struggling with central obesity and hormonal metabolic issues. And the trial showed that simply by adopting a high-fiber diet, these women significantly improved their metabolic risk factors and began reversing their insulin resistance.
The clinical data on fiber and metabolic health is undeniable. Fiber is the primary fuel source for your microbiome.
But I have to push back on the application of this.
Yeah.
If I am listening to this and I am currently suffering from severe inflammatory gut issues, let's say I have explosive diarrhea like Dr. Wentz had, or I have an active protozoal infection that has my gut lining raw and bleeding.
Okay.
Wouldn't adding a massive amount of dense dietary fiber to that environment be an absolutely terrible, agonizing idea? It feels like throwing coarse sandpaper onto a severe sunburn.
Your intuition is spot on, actually. And this is exactly why the architectural sequencing matters more than any individual piece of advice. Yes. You cannot build the second floor of a house if the foundation is currently sinking into a swamp. If you have an active root cause trigger like a hidden infection, a parasite, or a severe inflammatory response to an allergen like soy, your intestinal lining is highly compromised.
Right, it's damaged.
The tissue is inflamed, the tight junctions between your cells are leaking, and your localized immune system is in overdrive. If you introduce massive amounts of rough dietary fiber into that highly reactive environment, it will absolutely exacerbate the symptoms.
Just make it worse.
The fiber will ferment abnormally, cause severe bloating, feed the wrong types of bacteria, and mechanically irritate the damaged mucosal tissue.
So the timeline is everything. You have to repair the physical lining before you can optimize the microbiome.
Precisely. You synthesize the two approaches sequentially. First, you implement Dr. Wentz's protocol. You act as a detective.
Right, find the cause.
You run the stool tests, you try the elimination diets, you identify the hidden infection or the dietary trigger, and you eradicate it. You give the gut lining the time and the soothing nutrients it needs to rebuild its mucosal barrier.
Okay, that makes sense.
Then and only then, once the systemic inflammation has cooled and the structural integrity is restored, you begin to slowly scale up the dietary fiber to execute Cynthia Thurlow's protocol.
And how does that fiber actually translate into systemic hormonal balance? Because Thurlow was talking about reversing insulin resistance in menopausal women, which seems like a massive leap from just eating more broccoli.
It comes down to what the bacteria in your gut actually do with that fiber. When you have a repaired, healthy gut lining, the beneficial bacteria in your lower intestine ferment that dietary fiber and produce something called short-chain fatty acids.
Okay, short-chain fatty acids.
And the most important of these is butyrate. Butyrate is incredible. It serves as the primary energy source for the cells lining your colon, keeping them strong. But it also enters the bloodstream, travels to the liver and the brain, and actively regulates glucose metabolism. It reduces systemic inflammation and improves the sensitivity of your cells to insulin.
So you progress from acute survival mode to healing the root cause inflammation, and finally to feeding the microbiome to produce the exact chemical compounds needed for long-term hormonal optimization.
Exactly. The sequence is everything.
The mechanical progression of that is beautiful. We optimize the cellular baseline with our fire drills. We reprogram the immune software with our buckwheat polyphenols. We know how to use sugar and salt to survive an acute vascular crash. And we know how to sequence gut repair to balance our hormones.
We have physically optimized the body.
But here's the terrifying caveat in the research. All of that meticulous physical optimization is completely useless if the ultimate command center, the brain, is actively accelerating the body's aging process through unmanaged psychological stress.
Right. We are crossing into the mind-body aging axis now. And this is where the architecture becomes incredibly delicate. Because biology and psychology are not separate disciplines. They are a single, continuous feedback loop.
They feed into each other.
Yes, you can have the most pristine, polyphenol-rich diet in the world, but if your nervous system is trapped in a state of chronic psychological panic, you are actively destroying your own cellular hardware.
I was reading the longitudinal data from Dr. Terry Moffat, And it is sobering. I mean, she didn't just look at a small clinical group. She utilized massive multinational electronic medical records.
Yeah, we are talking about tracking hundreds of thousands of lives across different countries and healthcare systems over decades.
And her research revealed a glaring statistical link. Early life mental health conditions, like severe depression, chronic anxiety, and even unmanaged ADHD, are strongly, unequivocally linked to accelerated physiological decline and late-life chronic diseases, specifically dementia.
The scale of her data forces the medical community to abandon the outdated idea that mental health and physical health belong in two different buckets.
They are completely intertwined.
Dr. Moffat's team is proposing a radical shift in preventative medicine. If we aggressively repurpose cognitive behavioral therapy or early psychiatric interventions to resolve mental health struggles in a person's 20s or 30s, we could fundamentally slow down the biological pace of their aging in their 60s and 70s.
I think about it like a complex computer network. For so long, we viewed things like chronic anxiety or depression as a software glitch in the brain.
Right, like an app crashing.
Yeah, it's a bad string of code that makes the user experience miserable, but we assume the physical computer itself is fine. But Dr. Moffat's research is telling us that unmanaged anxiety isn't just a software glitch. It acts like a malware virus that overheats the motherboard and literally melts the physical hardware over time.
That's a terrifying thought.
Right. The longer the anxiety runs in the background, the faster the physical hardware, your heart, your vascular system, your brain tissue degrades.
And if we want to understand how that hardware melts down at the microscopic level, we have to look at the cellular engines. Dr. Scott Schur describes this exact physiological breakdown. He coined a phrase for it, actually.
What is
A
it?
sympathetic spiral of doom.
The sympathetic spiral of doom. It sounds like a terrible roller coaster.
It basically is, but the biology behind it is fascinating.
Walk me through it.
So your autonomic nervous system has two main branches. The sympathetic branch is your fight or flight response. It evolved to save you from immediate, life-threatening physical danger, like a predator.
Okay.
It floods your system with adrenaline and cortisol, spikes your heart rate, and mobilizes glucose for immediate muscle action.
But in the modern world, we aren't running from predators. We are facing constant, low-grade, unrelenting stressors. An overflowing email inbox, financial anxiety, traffic, unresolved childhood trauma.
Exactly, and your brain perceives these as existential threats, so your body becomes perpetually locked in that high-alert, sympathetic state.
And Dr. Schur points out that this constant, unbroken stress directly assaults the mitochondria. We all learned in high school biology that the mitochondria are the powerhouses of the cell, but how does an emotional state like anxiety physically break a cellular engine?
Because of the energy demand. When your brain is constantly signaling that you are in mortal danger, it demands an immense, unsustainable amount of energy from your cellular metabolism to prepare for a physical fight that never actually happens.
Right. The threat is in your head, but the energy is real.
Under normal, healthy conditions, your mitochondria are dynamic. They undergo processes called fission, where they divide to clear out damaged parts, and fusion, where they join together to share resources and maximize energy output.
But what happens during chronic stress?
Well, under the constant chemical load of chronic cortisol and sympathetic drive, this delicate network fragments. The mitochondria experience fission and fusion failure.
So they just stop working together.
They lose their structural integrity, they start leaking free radicals, and your cellular metabolism tanks. Your body is devoting so much energy to surviving the phantom psychological threat that it completely abandons the maintenance of your physical hardware.
So how on earth do we stop the spiral? Because telling an anxious person to just relax obviously doesn't work. Their mitochondria are already fragmented.
Right, just relax is terrible advice.
The research introduces Dr. Mariel Bouquet, who specializes in intergenerational trauma. And her approach isn't just cognitive. She focuses on creating a visceral feeling of bodily safety through somatic practices.
Yeah, she prescribes very specific physical interventions.
Right, like 5 minutes of daily intentional breath work, rhythmic body rocking to self-soothe, and humming. Humming to manually trigger the vagus nerve. And I have to admit, when I first read that, I was highly skeptical.
I think a lot of people are.
I mean, how can something as trivial as humming a tune physically communicate safety to an inflamed nervous system that is currently trapped in a mitochondrial spiral of doom?
Well, it sounds trivial until you look at the neuroanatomy. The vagus nerve is the longest and most complex cranial nerve in the human body.
Where does it go?
It originates in the brainstem, travels down through the neck into the chest, and branches out to interface with your heart, your lungs, and your entire digestive tract. It is the absolute superhighway of the parasympathetic nervous system, which is the rest, digest, and repair counterpart to the fight or flight system.
So if the sympathetic spiral is the gas pedal pressed to the floor, the vagus nerve is the heavy brake.
Exactly. But how do you manually pump those brakes when your mind is racing? The vagus nerve is intimately connected to your vocal cords and the pharyngeal muscles at the back of your throat.
Oh, I see where this is going.
Yeah. When you hum, you create a sustained mechanical vibration in those tissues. That physical vibration directly stimulates the vagus nerve fibers.
And what happens then?
When those fibers are stimulated, they release a neurotransmitter called acetylcholine. Acetylcholine acts directly on the heart to slow the heart rate, and it acts systemically to reduce inflammatory cytokines. That is wild.
It is a biological hack. You are mechanically massaging the nerve that sends a direct, undeniable chemical signal to your brain saying, the environment is calm, our heart rate is steady, we have the luxury of making noise, we are safe.
That is profound. You are bypassing the anxious thoughts entirely and using the physical mechanics of the throat to force the brain to stand down.
And the rhythmic body rocking, she suggests, operates on a very similar evolutionary principle.
How so?
Human beings are neurologically wired to associate rhythmic motion with early life safety. Rocking mimics the vestibular sensations of being in the womb or being held and swayed as an infant.
It's comforting.
It provides predictable, continuous rhythmic sensory input to the brain. When the brain senses that unbroken, predictable rhythm, the amygdala, the fear center, realizes it doesn't need to remain hypervigilant scanning for erratic threats.
Wow, so the rhythm downregulates the sympathetic drive.
Yes, the spiral of doom halts, and your mitochondria can finally resume their normal fission and fusion cycles to repair your metabolism. So we use these somatic tools, the breath, the humming, the rocking, to create a baseline of safety, which perfectly sets the stage for the next phase of our architecture.
Because if we just stop there, we are merely surviving.
Exactly. Once we have successfully calmed the nervous system and stopped the negative hardware melting stress, we actually have to turn around and intentionally inject positive physical stress back into the system. We have to build foolproof systems to strengthen the structure.
Yes, the mere absence of negative stress does not equal resilience. A building doesn't get stronger just because the wind stops blowing.
That's a great point.
You must introduce targeted, controlled physical stress to force the biology to adapt and build structural capacity.
And the research highlights some incredibly specific, almost extreme protocols for this. Let's look at what Tim Ferriss highlighted regarding the Emil Abramson protocol.
Oh, the hanging protocol.
Yes. This is specifically designed for strengthening tendons and connective tissue, which are notoriously slow to heal. And the protocol is shockingly minimalist. You find bar and you hang from it, but you don't do a full dead hang.
Right, your feet are on the floor.
Yeah, you support somewhere between 30% and 85% of your body weight. And the timing is rigid. You hang for 10 seconds on, then you rest for 50 seconds off. And you repeat that cycle for 10 minutes, twice a day.
It is the epitome of highly targeted intelligent stress. Muscles have a massive blood supply, so they heal and adapt very quickly. Tendons, however, are largely avascular.
Meaning they don't get much blood flow.
They receive very little direct blood flow, which means they take an incredibly long time to strengthen, and when they tear, they are agonizingly slow to repair.
So what does the hanging do?
By executing a low-impact, static, partial-weight hang, you are applying a highly specific, controlled mechanical load directly to the connective tissue of the hands, wrists, and shoulders. You are forcing those avascular tissues to adapt and build structural density without exposing them to the destructive wear and tear of explosive, heavy Olympic lifting.
So that builds the mechanical structure of the joints. But Ferriss also points to the Norwegian 4x4 protocol, which is on the completely opposite end of the spectrum.
Oh, yeah. That is a totally different kind of stress.
It is entirely about explosive cardiovascular effort. It involves 4 minutes of near maximum high-intensity interval training, followed by 3 minutes of active rest, and you cycle through that 4 times.
Right.
I know this is a premier cardiovascular protocol, but what caught my attention was Dr. Tommy Wood's neurobiological analysis of it. He noted that the massive surge of lactic acid produced during those 4-minute intense intervals is actually a major driver of positive neuroanatomical and vascular changes in the brain.
Which requires us to completely unlearn decades of outdated sports science. Seriously. If you played high school sports, You were taught that lactic acid was the enemy.
Oh, absolutely.
It's that burning sensation in your quads when you are sprinting. We thought of it as toxic exhaust building up in the muscle, a waste product that causes fatigue and soreness, and the whole goal of a cool down was to flush it out.
But Dr. Wood is suggesting that this burning exhaust is actually a critical signaling molecule.
It's literal fertilizer for the brain's vascular network.
That is exactly what the modern science reveals about the lactate shuttle. During an intense 4-minute burst, your fast-twitch muscle fibers cross the anaerobic threshold.
They're working too fast for oxygen.
Right. They are burning glucose so fast they can't use oxygen, so they produce massive amounts of lactate. This lactate spills out of the muscles and floods the bloodstream.
And it doesn't just sit there causing pain, right?
No, it travels up to the brain, and it is one of the few molecules that can efficiently cross the blood-brain barrier.
And what does it do once it gets inside the brain? It acts as an incredibly potent biological signal. First, the brain's neurons can actually use lactate directly as a highly efficient fuel source.
Oh, I didn't know that.
Yeah. But more importantly, the presence of high lactate levels triggers the release of BDNF, brain-derived neurotrophic factor.
Which is basically miracle grow for the brain, right?
Essentially, yes. BDNF stimulates neurogenesis, which is the growth of brand new neurons, specifically in the hippocampus, the memory center, and it simultaneously stimulates angiogenesis, prompting the brain to build new, denser networks of blood vessels to improve future blood flow.
So the severe physical stress of the Norwegian 4x4 forces the brain to fundamentally upgrade its own infrastructure.
That's exactly it.
So we have these highly effective biological tools. We have the Emil Abramson hanging protocol to build bulletproof tendons. We have the Norwegian 4x4 to flood the brain with lactate and trigger neurogenesis.
Yeah.
But there's a massive chasm between knowing a protocol exists and actually executing it every day.
Oh, a huge chasm.
Which brings us to the behavioral psychology of James Clear. He famously argues that human beings do not magically rise to the level of their lofty goals. Instead, we inevitably fall to the baseline level of our systems.
And he shared a fascinating case study about a reader named Mitch.
Yes. Mitch's story is a masterclass in the neurobiology of habit formation. Mitch was facing a massive goal. He needed to lose over 100 pounds. But the system he designed to achieve this was, on the surface, completely absurd.
That sounds like a joke.
Right. For 6 consecutive weeks, Mitch implemented a rigid rule. He forced himself to drive to his local gym, walk through the front doors, and then he forced himself to leave after exactly 5 minutes.
He literally couldn't stay longer.
Right. He wasn't allowed to stay and do a full workout. 5 minutes and he had to go home. Every single day. And I have to be honest, if I look at that objectively, I'm thinking, what a monumental waste of time and gas.
It does seem counterintuitive.
You are driving 15 minutes each way just to stand in a gym for 5 minutes. You aren't burning any calories. You aren't building any muscle. How does this system possibly contribute to the architecture of longevity?
Well, if you analyze it purely through the lens of caloric expenditure or physical output, it is a failure. But Mitch wasn't trying to build physical muscle during those first 6 weeks.
What was he building?
He was doing something much more difficult. He was building a neurological pathway. He was literally rewiring his brain's reward circuitry.
Explain the mechanism behind that. Why is the 5-minute cap so important?
It connects back to the sympathetic nervous system and the psychology of barrier reduction. If Mitch, who is heavily out of shape, sets a goal to work out for an hour every day, the psychological barrier to entry is massive.
It's too intimidating.
Right. On day 3, when he is exhausted, sore, and intimidated by the gym environment, his brain is going to perceive that hour-long workout as a threat. His amygdala will trigger that resistance, that fight-or-flight avoidance, and he will inevitably find an excuse to stay on the couch. But by capping the visit at a strict 5 minutes, he mathematically eliminated the friction of starting.
He made the habit so small that it was impossible to fail.
Exactly. He was mastering the art of simply showing up. In neuroscience, there is a principle called long-term synaptic potentiation. Neurons that fire together wire together.
So by physically going to the gym every single day, he was repeatedly firing the neural sequence of putting on his shoes, driving the route, and walking through the doors.
Yes. He was proving to his own brain, I am the type of person who goes to the gym.
So the neurological identity of the habit has to be cemented before you can demand physical results from it.
Precisely. You must establish the neurological architecture of the routine before you can scale up the physical intensity. Once those neural pathways were thick and deeply myelinated after 6 weeks, the friction of going to the gym was gone.
because it was just part of his day.
At that point, staying for 30 minutes or doing a Norwegian 4x4 interval became the easy part because he was already there.
That makes total sense.
When you place the physical stress of the hanging protocol next to the psychological discipline of Mitch's 5-minute rule, the unifying theme of this entire section becomes clear. Building resilience is not about raw, unsustainable, white-knuckle effort.
It is about implementing high-leverage systemic inputs.
You don't need to destroy your body in the gym for 3 hours, and you don't need to rely on fleeting motivation. You just need an unbreakable system that guarantees consistency.
That reframing is incredibly empowering. The system itself is the scaffolding of our longevity. So let's look at what we've built so far. We have an incredible optimized physical structure.
We've covered a lot of ground.
We really have. We've dialed in our cellular baseline. We've used epigenetic software to reprogram our immunity. We've healed the gut. We've used somatic practices like humming to break the nervous system. And we've built resilient joints and a highly vascularized brain through consistent, systemized physical stress.
We are, on a biological level, pristine.
Pristine. But when we look at the final chapters of our research, there is a looming existential warning.
Yes, there is.
If we stop our work here, the entire beautiful building will eventually collapse in on itself.
Because you have engineered a magnificent, resilient shell, but an architecture without a purpose is ultimately vacant.
Wow, yeah.
You can have the most perfect mitochondrial function and unbreakable gym habits in the world, but if you lack a deep existential reason to wake up in the morning, and if you lack a tribe of humans to share that life with, the biological mechanisms will eventually sense that isolation and initiate a systemic shutdown.
And this brings us to the highest level, the social and existential architecture of longevity.
This is where it all comes together.
Dan Buettner's extensive research into the blue zones is the perfect entry point here. He spent years analyzing these very specific demographic regions across the globe, places like Okinawa, Japan, and Sardinia, Italy, where people routinely live past 100 years old with immense vitality.
And while their diets and physical habits varied, the universal through line was the sheer power of deep interwoven social connection.
So Buettner took this data and started engineering modern social frameworks in American cities, creating what he calls moais.
The concept of the moai originates in Okinawa. It is essentially a committed, lifelong social support circle. But what is fascinating is how Buettner engineered these in modern, deeply isolated Western cities.
Right. How do you force that kind of connection?
He utilized the underlying psychology of human connection. He actively recruited individuals who self-identified as lonely or isolated. He had them self-select into small groups of 5 people.
And then, crucially, he gave them a shared goal, a 10-week walking competition against other groups.
And the longitudinal results of that simple intervention were absolutely staggering. A full 60% of those people were still walking together, still maintaining those deep social networks 4 years later.
A manufactured 10-week walking contest yielded a 4-year, life-extending social bond. That's incredible.
But as we dig deeper into the neurobiology of this, it becomes clear that it is not merely about walking in physical proximity to someone else. It's about the depth and the chemical nature of that connection.
And Dr. Andrew Huberman touches on this beautifully. He talks about how he was actively deepen our bonds, and he suggests a very specific intervention. Looking a friend in the eye and asking them a highly vulnerable, unexpected question.
Specifically, what is in your heart?
What is in your heart? That phrasing is so intentional.
It is, and it functions as a powerful neurobiological intervention. In modern society, the vast majority of our daily interactions are highly transactional or superficial. We are constantly managing our social image.
And because of that, our brain's vigilance circuits remain slightly activated.
We are perpetually wearing a social mask, which requires continuous low-level cognitive energy and maintains a subtle sympathetic stress response.
So when I think about vulnerability, the terrifying act of dropping that mask, looking someone in the eye, and actually articulating the truth of what is weighing on my heart, I picture that act as a biological off switch. It physically deactivates the brain's internal security alarm.
It absolutely does, and the chemistry proves it. When you combine the collaborative shared goal dynamic of Buettner's moais with the raw vulnerability that Huberman is advocating for, you are fundamentally altering brain chemistry.
How so?
Sharing deep, unvarnished truth with a trusted group signals profound evolutionary safety to the nervous system. The brain registers that it is part of a protected tribe.
And what happens to the amygdala?
It completely deactivates. It shuts off those stress-inducing vigilance circuits that drive the sympathetic spiral of doom we discussed earlier.
That is amazing.
And the downstream effect is beautiful. When the brain is no longer wasting metabolic energy on social vigilance and fear, it reallocates that energy to the prefrontal cortex. It expands your capacity for cognitive creativity, empathy, and problem solving. True vulnerability literally allows your biological systems to rest, repair, and expand.
The idea that social connection acts as literal medicine for our cellular hardware is incredible. And this moves us to the final existential layer of our architecture, how we construct our own internal reality and purpose.
This is a really important layer.
I was reading a story about Dr. James Doty, a clinical professor of neurosurgery, and it left me in pure astonishment. Dr. Doty advocates heavily for the concept of manifestation.
But he is a neurosurgeon, so he completely strips away the mystical, pseudoscientific veneer.
Exactly. He roots manifestation strictly in neurobiology. He talks about intentionally programming a region of the brain called the salience network.
The salience network is a fascinating piece of neurological hardware. Think of it as the mind's ultimate filtering algorithm, or a highly trained bloodhound.
Okay.
At any given moment, your sensory organs are bombarding your brain with millions of data points, sights, sounds, conversations, environmental details. Your conscious mind cannot possibly process all of it, so the salience network filters out the noise.
It flags only what it deems important based on your deeply held internal goals, fears, and intentions.
Right. Dr. Doty argues that if you spend time clearly, intensely visualizing a specific goal, you are actively programming that algorithm. You are training the bloodhound to constantly scan your environment for subtle opportunities, conversations, or pathways that you would normally ignore.
And the way Dr. Doty applied this neurobiological principle to his own life is the stuff of legend. When he was younger, he decided he was going to go to medical school. But on paper, his reality was a mathematical impossibility.
Yeah, he had a 2.53 GPA, he hadn't completed his degree requirements, and he came from a severely disadvantaged background.
The system was designed to reject him instantly. But he had spent months visualizing his goal. He had programmed his salience network to see no other acceptable reality. And when the time came, he managed to get an interview, but the committee was hostile. They told him he was unqualified.
But the story goes that he simply refused to leave the office.
He sat in the chair, and he began to lecture the admissions committee on his own humanity. He refused to be reduced to a statistical data point. And he spoke with such profound, undeniable conviction and intention that the committee members actually began to cry.
Which is just, wow.
And despite every rule and metric, they gave him their highest recommendation, and he was accepted. The sheer, terrifying audacity required to sit in a room of hostile authority figures and demand your future is unbelievable.
It is extreme audacity, yes, but it perfectly illustrates the power of an aligned neurological system. It was a perfect synthesis of intention and action.
He didn't just sit in his room passively wishing to become a doctor.
No, his salience network recognized that sitting in that chair and confronting the committee was the absolute only viable path forward to achieve the reality he had programmed. His brain perceived retreat as a failure of survival, so it drove him to take a radical, deeply uncomfortable action.
That is the ultimate power of focused intention. But our research stack also provides the vital counterweight to that intense drive, which is the practice of radical acceptance.
Which is just as important.
Days Evans, who is well known for his work in design thinking, teaches that true meaning is not always found in bending reality to your will. Often, meaning is found by fully participating in the reality you are handed, no matter how painful.
And his personal story is heartbreaking, yet incredibly illuminating.
His late wife received a devastating terminal cancer diagnosis. And human nature, our immediate reflex, is to fight that reality. We stay trapped in a state of angry, panicked resistance. This isn't fair. This can't be happening.
But Evans and his wife consciously chose a different path. They practiced radical acceptance.
They reframed the terminal diagnosis with a very specific phrase. They called it sad, not tragic.
That specific linguistic framing, choosing to define the event as sad, not tragic, is the highest psychological manifestation of turning off the sympathetic spiral of doom.
How does the wording change the biology?
Well, the word tragic implies an ongoing, bitter war against reality. It implies a state of perpetual shock, denial, and resistance that keeps the nervous system locked in a traumatized fight-or-flight state.
You are spending all your biological and emotional energy fighting a battle that cannot be won.
Exactly. But the word sad acknowledges the profound, unbearable grief of the situation, while simultaneously accepting the undeniable reality of the present moment.
And by accepting it, by refusing to burn all their energy, resisting the truth of her diagnosis, they created the emotional space to actually live.
They were able to find profound gifts, deep connection, and beautiful meaning in her final months. They didn't miss the end of her life because they were too busy denying it was happening.
It is the perfect synthesis of every concept we've explored today. Radical acceptance is the ultimate form of systemic resilience. You cannot control every outcome,
You cannot prevent every disease or avoid every tragedy.
but you retain absolute control over the architecture of your response. By accepting reality, you protect your biological hardware from the ravages of chronic panic, and you preserve your psychological capacity to find meaning in the time you have left.
So what does this all mean for us?
Well, this has been an incredibly expansive, perspective-altering journey today. We started at the absolute microscopic floor, learning how to hack our cellular baseline, utilizing low insulin and buckwheat polyphenols to trigger false danger signals and rewrite our immune software,
We learn the raw mechanics of how to survive acute vascular crashes with emergency sugar and salt.
and how to sequence the repair of our gut's hidden command center to optimize our hormones. We moved up into the mind-body axis, utilizing the physical mechanics of humming and rocking to break the vagus nerve and shatter the sympathetic spiral of doom.
We built resilient structural systems through 10-second tendon hangs and 5-minute gym rolls.
And finally, we anchored that entire biological structure in profound social vulnerability, the neurobiology of clear intention, and the incredible peace of radical acceptance.
And as we close this deep dive, I want to leave you, the listener, with a final overarching paradox to reflect on. It is a thought that I believe captures the true essence of this entire architecture.
I'd love to hear it.
If you look back at our first section, we learned that giving our physical cells a false danger signal by restricting resources through fasting or inhibiting insulin actually fortifies the body and extends our physical life. It forces the physical cells to adapt and become resilient.
Right.
But when we look at the final section, we see the exact opposite is required for the mind. We learn that giving our brains a true safety signal through radical acceptance, deep vulnerability, and unwavering social connection is what turns off the destructive stress response and protects our systemic hardware.
That is brilliant distillation.
Yeah.
False danger for the physical body, true safety for the psychological mind.
Precisely. And perhaps the ultimate architecture of longevity isn't found in any single diet or protocol, but in mastering that exact delicate balance. It is the wisdom of knowing exactly when to tell your physical body that it is in danger, and knowing exactly when to tell your soul that it is perfectly safe.
That paradox is something I am going to be unpacking in my own life for a very long time. Thank you for joining us on this deep dive. Take these concepts, test these protocols, reduce your barriers, and begin constructing your own resilient architecture of longevity. We will see you next time.